Kia ora Year 10. This is an extended abstract problem from circle geometry, and this is in the JAF Practice worksheet that we've given you. So we have to here find the size of angle DFA, and we've got a circle. We have to explain what we're doing at each step and use full geometric reasons. So one thing to make sure you do with harder problems like this is not to rush into it, but to start off by just working out what information we've got. The first thing to notice in here is that point O is the centre of the circle. That could come in handy, right? Because once you remember that this is the centre, then we know that that means that BOA is a diameter. And the angle in a semicircle, when we've got the diameter, is 90 degrees. So that might come in useful or it might not. There are lots of ways to solve this problem. The next place that I look to start is with angle DEA, and that's 31 degrees. Now we know that angles formed by the same arc are equal. So if we take the points D and A and look at where there's another angle formed by those, we can see that angle DBA must equal 31 degrees. And that's where I'm going to start out with some formal writing down some new angles and writing down reasons next to them. Okay, so angle DBA is equal to 31 degrees. And that's because angles on the same arc are equal. So we write the first number and then we write the reason. So this is 31 degrees. Now there are quite a few places I can go from here, but what I'm going to do next is use the fact that this is the centre of the circle. So that means that triangle DOB is isosceles, and that's because the radii are equal. And that tells me that angle ODB, this one here, must equal 31 degrees. Because the base angles in an isos triangle are equal. Right, I've already said up here that we've got equal radii. So this one is 31 degrees. Now that means that I know this angle here must be 61 and this one's 31. So I can now find this angle here. So angle BFD is equal to 180 minus 31 minus all of that. So what does that work out to be? Well, that's 180 minus 92 degrees. So that's 88 degrees because angles in a triangle equal 180. Now there is a faster way to do this, but I'm doing it this way first. So we know this is 88, and so the one we're after is really easy. We're just going to use the Year 9 rule about angles on a line. So angle AFD, or DFA, is equal to 180 minus 88, which equals 92 degrees. So that's what we had to find, so we're finished. But I'm going to show you two other sets of reasoning that would have got us there. So let's go back to just a little bit back, forget this bit and this bit. So we've found that we've got these two 31 degree angles. How else could we have done this? Well, one of the rules that we tend to forget from Year 9 is that the exterior angle in a triangle, this one here, is equal to the sum of the interior opposites. So we can go straight to our answer, and we could have written angle, DFA is equal to 31 degrees plus 30 plus 31 degrees, because the exterior angle in a triangle is equal to the sum of the interior opposites. So that's two ways. Now the last way that you could use is that we could use this whole angle having to equal 90. Right, I'm not going to write this one all out, but it's just one more way to reason it. So this angle in here must be 29 degrees. And then what can I say? Well, I've got 29 degrees here. And I've got 30 degrees here. Let's see, what else can I do? I can use that to get So this one's 90, this one's 31, so then I can get this angle in here as 90 plus 31, so that's 121. That leaves me 89 degrees here, and then I can use angles in a triangle to get the one that I want. So that's a third, slightly clunkier way of doing it, but it will get you there. And it doesn't really matter what you choose, as long as you can communicate your reasoning really logically. I've used the shorthands for that, because that's what I've taught in my class. If you would prefer to write out that as a whole sentence, you can. It's just that it gets a little bit time consuming. I'm going to do some relational questions soon, but if you're looking for more practice on harder ones like this, there are some on Education Perfect, and there are also some in the Dr. Frost Maths tasks that I've set you. Thanks for watching.